Lesson 8.2, Characteristics of Quadratic Functions. So on this lesson we are continuing with quadratic functions. And remember, for it to be a quadratic function, your x has to be squared. So for example, y is your function. Y is your function. And then if you have something like x squared plus 3x minus 4, that would be considered a quadratic function because your x is squared. And quadratic functions are written in the form y equals ax squared plus bx plus c. Okay, so let's review x-intercepts before we get into this lesson. You can see here that I've graphed a couple of x-intercepts. That's where they cross the x-axis. Okay, you notice for it to be an x-intercept, y is going to be 0. That's what I have written here. If it's an x-intercept, then y equals 0. Okay, that leads us into 0 of a function. Okay, well if you know that function form means y is by itself, then the function is y. So if I want the 0 of a function, then I know y has to equal 0. Therefore, the 0 of a function and your x-intercept are the exact same things, because in both cases, y is 0. Right, a quadratic function may have 1, 2, or no zeros. So for example, if it has 1 0, that means it has 1 x-intercept. And if I graph that, if I graph a parabola that only has 1 x-intercept, it might look something like this. Okay. If we have 2 zeros, that means I have 2 x-intercepts. So let's graph a parabola that has 2 x-intercepts. Anywhere on my graph I could have 2 x-intercepts. So let's say I have one right here and one right here. This parabola might possibly look like this right here. And then no zeros means I have no x-intercepts. An example of a parabola that does not have any x-intercepts or zeros would look something like this. Okay, it never crosses the x-axis. Alright, moving right on along. Finding zeros of quadratic functions by graphing. Okay, here's our function. Y equals x squared minus x minus 2. So we're going to graph that. And I would recommend y'all graph it in your calculator. Okay, we're going to go to y equals. And we're going to put in x squared minus x minus 2. Bring up your table. Let's use x, negative 2, negative 1, 0, 1, and 2. When x is negative 2, y is 4. When x is negative 1, y is 0. 0, negative 2. 1, negative 2. And 2, 0. Alright, let's graph those points. I have negative 2, 4. Negative 1, 0. 0, negative 2. 1, negative 2. And 2, 0. Alright, when we graph our smooth curve, it's going to look something like this. Okay? You've now graphed that parabola. Now we want to find the zeros of the function. Remember, zeros of the function is where your y equals 0. Therefore, I know it has to be your x-intercepts. So the 0 of this function looks to be at -1 and 2. And if I look at my table at -1, y does equal 0. And at +2, y equals 0. So there's your zeros at -1 and 2. What are the zeros? -1 and 2. Okay, look at B. B, and I'm going to graph it. Y equals -2x squared plus 4x minus 2. Bring up my table. And I'm going to use the points, I don't know, let's use 0, -2, 1, 0, 2, -2. If I graph 0, -2, 1, 0, and 2, -2, I can see that this parabola is going to look something like this. Well, how many zeros do I have? How many functions, zeros of functions do I have? I can see I have one x-intercept, therefore y equals 0. Therefore, I have 1 0, which is at 1. What are the zeros? 1, 0. Okay. Alright, let's graph y equals 1/4 x squared plus 1. Bring up our table. I'm going to say x is -2, 0, 2, and 4. When x is -2, y is +2. X is 0, y is 1. X is 2, y is 2. And x is 4, y is 5. So let's plot those points. -2, 2. 0, 1. 2, 2. 4, 5. I'll draw that smooth curve. How many zeros do I have? Does it ever cross the x-intercept? No, it doesn't. So I have no zeros. Alright, now let's talk about axis of symmetry. And if you're following along on your app, we're on chapter 8, lesson 2. Talking about the axis of symmetry. Axis of symmetry, that is a vertical line. Vertical means it goes straight up and down. A vertical line that divides a parabola into two symmetrical halves. Okay, so here we have a parabola. Your axis of symmetry divides this parabola into two symmetrical halves. Okay, that's my axis of symmetry. It always passes through the vertex, and you can use the zeros to find the axis of symmetry. Okay, and if you'll review the chart on lesson 8.2, this will explain this even further. And the chart's in the middle of the lesson if you scroll down. Alright, let's practice finding the axis of symmetry using zeros. Remember, an axis of symmetry divides a parabola into two equal parts. So, here we have the axis of symmetry. Remember, it always goes through the vertex. Well, here's my vertex because it's the highest point on this parabola. So the axis of symmetry has to go through the vertex. Okay, so my axis of symmetry, this vertex looks to be at 2, 0. So my axis of symmetry would be x equals 2. on B. Okay, my zeros look to be at 1, 0, 5, 0. The axis of symmetry divides these into two equal parts. So I'm going to take my zeros, which are 1 and 5. So I'm going to say 1 plus 5, and I'm going to divide it by 2. 1 plus 5 is 6. 6 divided by 2 is 3. So my axis of symmetry is at x equals 3. So I'm going to put my vertical line going through there. There's your axis of symmetry. There's also a formula for finding the axis of symmetry. You don't always have to use the zeros because sometimes there isn't a zero. So therefore we need to know how to find that axis of symmetry. Well, here's the function form, y equals ax squared plus bx plus c. The formula for finding the axis of symmetry is right here. X equals negative b divided by 2 times a. So in example 3, let's find the axis of symmetry by using the formula. Remember again, here's your form. The formula is x equals negative b divided by 2 times a. So I need to know my values of a and b. So by looking, I can see that a is the number before the x squared. So in this case, it is 1. B is the number before the x. In this case, it's 3. So I'm just going to take these values and plug into my formula. So x is going to equal negative 3 divided by 2 times 1. So x equals negative 3 divided by 2. X equals negative 1.5. Okay. You just found your axis of symmetry by using the formula. And now we're talking about finding the vertex of a parabola. Remember, your vertex is your highest or lowest point on a parabola. Okay, those points would be the vertex. So the steps to finding the vertex is you have to find the x-coordinate of the vertex by finding the axis of symmetry. And we can use that by using the formula x equals negative b divided by 2 times a. There's your x-coordinate. To find the corresponding y-coordinate, you're going to substitute the x-coordinate of the vertex into the function. So once you find x, you have to find y. And then you're going to write the vertex as an ordered pair, x, y. So let's practice doing that. Going to find the vertex of this parabola. First we have to find the x-coordinate by using the formula x equals negative b divided by 2 times a. Here's our form. It is in the form y equals ax squared plus bx plus c. So my value of a, I can see, is negative 1. B is negative 2. So I'm going to plug these values in. I have x equals negative, and then I'm going to have negative 2 divided by 2 times negative 1. So x equals negative 2, negative 2 divided by negative 2. And you can put this just in your calculator as is, just make sure your fraction's in parentheses. And when you do that, you get x equals negative 1. So when I write the ordered pair, I know that x is negative 1. I need to find my y. Well, to find the y, I can plug the x value into the function. So I'm going to have y equals negative 1 squared minus 2 times negative 1. If you want, you can put just this right here into your calculator or write it out. So we have y equals negative 1 squared is negative 1 times negative 1, which is positive 1. So, and I have this negative in front, so I have negative 1 plus 2, which gives me 1. Here's your vertex at negative 1, 1. So let's check. Does the vertex appear to be at negative 1, 1? Yes, it does. Okay, B, we're still finding the vertex, but this time they didn't graph it for us. That's okay, we can still find the vertex. Remember, first step, to find the vertex, you have to know your x and y. So to get your x, you're going to use the formula x equals negative b divided by 2 times a. I can see that a equals 5, b equals negative 10 by looking at my function. So then I'm going to plug in. I'm going to have x equals negative. We have that negative out in front. And then I have negative 10 divided by 2 times 5. So I have x equals negative 10 divided by 10. So if you're putting that in your calculator, you could put x equals negative 10 divided by 10. And you are going to get x equals positive 1. That's a plus plus. Okay? So writing the ordered pair, I know my x is 1. Now to find my y, find the y coordinate, I'm going to plug in my x value into the function. So I'm going to have y equals 5 times 1 squared minus 10 times 1 plus 3. Just put this in your calculator. Or we're going to have y equals 5 minus 10 plus 3. Y equals negative 2. There's your vertex. 1, negative 2. Okay, and then look at example 5, the architecture plan. I know most of y'all have driven down the interstate and you've seen the bridges, the underpasses that we go under, and I know y'all have seen the signs that says like 10-foot clearance. Well, how do they know it's a 10-foot clearance? Where does that come from? Especially if it's in the shape of an arch. Well, you can see on example 5 on our architecture application, it says the height, we're talking about a ship passing under this underpass that has water under it. We have an arch that is supporting the bridge. And it wants to know, can a sailboat that is 24 feet tall pass under this bridge? Well, it tells me that the height above water level of a curved arch support for a bridge can be modeled by f of x equals negative 0.007 x squared plus 0.84x plus 0.8. Okay, well, if you're looking at your graph, you can see we have a coordinate plane drawn in there. The x-axis is the water level. The y-axis is the height of the bridge. Okay. So the vertex represents the highest point of that arch support. We have our arch support here. Here's my water level. Here's the bridge that's on top of that arch. Here's my y-axis. Can a 24-foot sailboat sail under this arch right here? Well, I have to find the highest point on this arch, which in the shape of a parabola, the highest point would be the vertex. Well, to find the vertex, I have to know my x and y. Okay, I know I can find the x by using the formula negative b divided by 2 times a. I can see that my a is negative 0.007, and I can see that b is 0.84. So if I plug these values into the formula, I have x equals negative 0.84 divided by 2 times negative 0.007. So I get x equals negative 0.84 divided by negative 0.007 times 2. gives me 0.014. So negative 0.84 divided by negative 0.014, I know that x is going to equal 60. So on my vertex, I know that x is 60. How do I find the y? I'm trying to find this highest point, this y right here. I'm going to plug the 60 in for x. So I'm going to have negative 0.007 times 60 squared plus 0.84 times 60 plus 0.8. And then I'm just going to put that right there in my calculator. Negative 0.007 parentheses 60 squared plus 0.84 parentheses 60 plus 0.8. So I know that y equals 26. So this highest point right here, the highest it's going to be is 26 feet. Okay? So can a 24-foot sailboat sail under this? Yes, it can with the 2-foot clearance. So yes. Alright, and here's your assignment for this lesson. Looks like 20 through 36 evens and 41 through 42.